NASA's PI, the principal investigator. Can you just please identify yourself?
Yeah, my name is Jens Redemann. I work for the NASA Ames Research Center in California.
And you're part of the Oracles project.
That's correct. I'm the principal investigator. That's sort of short for chief scientist for
The
the whole
chief
project.
scientist, ooh, fancy.
No, yeah, that sounds bigger than it is.
What does Oracles mean? NASA loves the acronyms, so what does that actually stand for?
It's for observations of aerosols and radiation above clouds, essentially, in a nutshell. You know, we
Above
don't.
clouds.
Yeah.
That's the CL. Okay.
Correct. And their interactions.
And their
We
interactions.
borrowed an E from interactions and an S from interactions. It's a very cheeky way of doing it. So nowadays you don't have to have the first letter.
Yeah, it
anymore.
doesn't have to fit everything. Okay. And you're using the two planes, the ER2 and the
The P3.
P3, right. How did that work? How did you get the planes here?
Well, it was a little bit of a process. Those are two of the five research planes owned by NASA. They are very well equipped for doing the kind of things we like them to do. So the ER2 is an aircraft that flies at very high altitudes, 65,000 feet, and acts as a sort of our own mobile satellite, if you will.
Okay.
So it's not stuck to an Earth orbit like some of our satellite assets. But it carries very much similar instrumentation, except that it carries newer, better, more sensitive instrumentation. So the way you want to think of it is that we develop instruments that eventually are supposed to go to space, and we put them first onto the ER2 aircraft to test their ability to observe the atmosphere, the environment, climate, air pollution, those kinds of things. And if they do well on the ER2, then we consider them for space deployment.
Wow, okay. So it's a whole process that you go through before it actually reaches space,
That's
before it's actually
absolutely
signed for. It's like, okay,
Which
this is
is-
very good. We can
which-
use it in space.
Exactly right, which is at any given time, the reason why at any given time the instruments that are in space are probably about 10 years behind the technology development of the aircraft instruments that we can fly on the ER2, because it's a
Wow.
long process
So it's
to
a
get
long process.
to get the instruments
So all
into
satellites
space.
are essentially out of date.
In some sense, yes,
some
absolutely correct, yes.
And it was a long process getting the planes here. So the planes originated from NASA headquarters, or
They're owned by different NASA centers. The P3 is
Okay.
owned by NASA Wallops in Virginia. The ER2 is operated by NASA Armstrong Flight Research Center, AFRC, which is a very new outfit. They just changed their name. It used to be Dryden. So
Okay.
everybody has to rethink their name for this. And they run two or three of the five NASA aircraft that we use for research like this.
yeah. Now the ER2, is that the propeller, or is that that's
No,
the high orbit one?
The ER2 is the high flying aircraft,
That's the-
single engine. The P3 is a four
P3
engine
is the four-
turboprop engine.
Turboprop engine.
Mm-hmm.
It seems dodgy flying around 9 hours in that thing.
Well, I've done it multiple times this season alone, and you know what? Interestingly enough, it's safer than flying commercially because
Really?
Yeah, because there are more people looking after one aircraft, and they look at it every flight. So I've had the experience to fly with crew members from the P3 ground crew that maintain the aircraft, and they're much more scared going onto a commercial flight than flying on their own aircraft.
Well, I suppose that makes sense because the commercial is all about the money in the end. You know,
Getting them quickly
You
from
can
A to B,
yes,
correct.
so that makes a lot of sense because if it's your plane and you know your life is in your hands, you're gonna make sure that thing flies.
On the other hand, we ask them to do things that you wouldn't ask a commercial aircraft to do.
Yes,
of course,
okay,
so-
obviously. Now, when you got here, and I love the transparency, I've mentioned this before, but you've been so transparent and open with everything that's been happening, and you try and explain it multiple times what you're doing, how you're doing it, and all
Right.
kinds of things, with presentations and slides. But do you think people are actually understanding what's happening, or is there still some hesitation?
It's probably not for me to judge. I think it's a complicated process that we're going through. Not many countries in the world run a research institution like NASA, and I don't blame people for struggling to understand the workings. So NASA is a completely civilian outfit. We do research to benefit mankind, essentially. One of our mandates is to protect the Earth and to understand the Earth as a planet, as a habitable planet for ourselves. and there's significant investment in monitoring the environment and its changes, and monitoring climate and its changes. And so we are here to study processes that are relatively poorly captured in climate models. So we collect data to test the models that will predict future climate, and we would like to make sure that those improvements in the climate models then make it back into policymakers' decision-making processes, basically. So point being that if you have better, less uncertain predictions of future climate, then policymakers can make better decisions for emissions of fossil fuel burning.
Okay,
things.
so the data and the research that you're doing now has long-term benefits,
Absolutely.
not just for studying climate and forecasting the weather, but also for fossil fuels emissions, carbon emissions, all kinds of things. So it's a very important study in my view.
That's correct. Yeah. So we know that our activities, human activities, are tending to warm climate because of our greenhouse gas emissions. But there are other things that tend to cool climate. So these particles that we put into the atmosphere, including biomass burning particles that we're studying here, are believed under certain circumstances to cool climate. So we're basically studying but the processes are very poorly understood because of these particles being so short-lived. So the point is, greenhouse gases are long-lived, they're easy to study. These cooling parts of the climate system, or how humans force the climate system, are very poorly understood because the agents that are doing the cooling are very short-lived. So an aerosol particle like the ones that are emitted from the fires only lives for a week or two, and that makes it very difficult to capture in a climate model.
But climate change is a very controversial subject.
Correct?
And not many people either believe it's happening for some reason, but you can understand now that it's controversial because they say science says this, science says this, because not only is the Earth warming from the greenhouse gases, but in a sense with these clouds and everything, it can also be cooling. So it's a sort of a give and take. So that makes sense why climate change would be a controversial issue.
Yeah, I used to be very politically correct about answering questions like that, but really there is no question about whether the Earth is warming.
It's warming,
And
there's no question about it.
Exactly, and there's very little question whether humans have something to do with it.
No, it's humans. Honestly, if you're not going to be forthright about this, then nothing's ever going to happen.
That's absolutely correct. And, amongst the scientific community, there's about 97% consensus that it is warming and that is humans most likely causing the warming. So it is foolish to find the 1 to 3% that have an alternate agenda and put them on a camera interview with the ones that are not, and pretend there's some sort of an equivalency in their arguments.
Pseudoscience.
Correct.
Okay.
In my opinion.
Now, NASA is a civilian body, but
Correct.
it's also part of the government.
Correct.
And the government recently, I don't know how recently, but I think it was this year, where they made some changes to NASA's budget. Has that influenced the Oracle's project in any way?
No, it has not, as a matter of fact. The vehicle under which Oracles is funded is called the Earth Venture Program, and it is a direct response to there was a decadal survey organized by the Academy for the Advancement of Science in the US, and the panel recommended that NASA engage in suborbital science in addition to some other satellite studies. And what we call suborbital studies, meaning not space studies, are a direct consequence of this directed funding since 2008 or 2009. So this is only the second round of them, and so we have fared quite well under this. And these changes happen all the time. There's always a rebalancing of space versus solar versus planetary versus Earth science all along. But other scientists have different priorities, and for good reasons, and understandably so.
But everything is important. Science, in general, is an important facet of life and living and the future, really. So I think everybody has their own sort of ways. Like, yes, my science is better science.
Right.
But it's like, it's not better science, it's different science.
Correct.
And it's got a different outcome and everything, also beneficial. But I understand why people are sort of, everybody wants a slice of the cake, sort of.
That is correct. For climate scientists in particular, though, the projections are pretty dire at this moment in time, such that, even under the most favorable emission scenarios, it appears that we are on a trajectory to warm climate more than we understand what the consequences will be in such a changing climate. So there's theories of tipping points beyond which there's no return. Even at this moment in time, if we stopped emitting greenhouse gases, there would be no stopping and warming for several decades, because a lot of the heat that we have induced in the system is stored in the oceans and would be released into the atmosphere. So there's some warming that we have already pre-programmed for the next 1 or 2 generations of our children. So not doing something right now seems grossly negligent, quite frankly.
I know you're trying to be politically correct and putting a nice face on it, but I'm telling you, if you don't do something now, it's just plain stupidity.
It is not fair to our
It's
children.
not fair. It's not fair.
Yes.
And you can say, "Oh, but it's their problem." It's like, it's your problem.
That's correct.
You're living here now. What's it like working with so many different people? I know some are from Miami, some are from Israel. Is it difficult to get everyone grouped together and working on the same project? Or was it?
That's an interesting question. I haven't been asked that, so I don't have a prepared answer for you. But I would say it's actually not that difficult, because the common denominator is this interest in science, and it doesn't matter where people are from. It didn't matter that the 9 Namibian students that we involved in the project, where they were from exactly. I'm not here as a U.S. person. I grew up in Germany. I'm here as a global citizen, frankly, to study a problem that I know will make an impact on projections of climate. And frankly, I feel that from the entire team, the entire 108 people that were here to support the mission, from every engineer to every crew member of the aircraft to every scientist. And from that, just knowing that, it was pretty simple to lead the team, because everybody was sort of on the same page as why we're here and why this is important.
That's cool. That's really incredible, because it shows that people are coming together for a common goal, not basing on, oh, but I studied this and I studied this and I come from this and we do it this way. Everybody is focused on the exact same thing.
Correct.
And everybody's working well together.
Correct.
And that's really something I think we can take away from this, that it's important, get your act together, work together, and get something done.
Couldn't have said it better myself.
Okay. Thank you for your time.
Yeah, no worries.
And I know you're late for dinner.
Brandt,
So
yeah,
I'm going to
thank you for your
leave you
time.
this. Thank you so much.